I've got 16 pass, guys. Is this the normal sort of numbers we're getting these days? Costa Rica. Oh, okay. Well, part of my talk, which was specifically for the people in Costa Rica, is going to go on deaf ears there. Are there people who know who are coming later? Should I close this?
Maybe 100.
I'll leave it open for Alright, so the purpose of today's seminar is two things. One, I want to talk about the importance of science communication, why it's so important, why it's been a bit shit in the past, what you guys need to look out for if you are going to go into a job where science communication is necessary. And then for the second half, we're going to focus on the actual assignment. There's been a lot of questions, some which I can't really answer in an email because I want to go into a bit more of a discussion about it. And then there'll be time for your own questions, whether it's on this or on the assignment, and the course in general. So, let's get started. Now, who has a rough idea of what science communication is already? What's your definition?
Can I say vulgarization?
A vulgarization? Yeah, sure.
Makes it understandable for non-scientific people.
Where's the vulgarization there?
Yeah.
That's fine. Yeah, making science understandable for non-scientific people. Now that could be anything from a board of policymakers. Say if you're working with the industry and you're working with a company that wants to expand, build a new building, new outlet, new power outlet, that sort of thing, and you've been asked to come in and say, should they build here? Should they not build here? Is it going to ruin a habitat? That sort of scientific communication. Or it could just be dissemination of interesting stuff to the public at a museum, for instance. It encapsulates a whole range of stuff. What David Attenborough does is science communication. What we do at a museum is scientific communication. A biodiversity consultant within an industry or the banking industry is scientific communication. And the reason I want to talk about it is because it's something that's not taught enough from an early level. It's something I feel people should be introduced to at the start of their education in science. And when I say the start of their education in science, I know some of you are bachelors here. I don't mean that. I mean they should be taught about the importance of being able to convey scientific ideas when you're learning about why the Earth goes around when you're 6 years old. Whilst teaching somebody why it does go around is really cool, teaching somebody to explain that to someone else is also a really good idea. So I'm going to be mainly focusing today on communicating to the public, as in to just a general audience. But if you have any specific questions, again, about communicating with policymakers, industry, that sort of thing, please stick your hand up and ask. This is a lot more subjective, a lot less fact-laden than the other talks that I've given. So, if I can get this thing working, what I'll be going through again is why it's so important today, why it has been a bit crap in the past, some of the real problems that science communicators have had and have fostered themselves, really. Whether or not it's gotten better over the last 10, 20, 50 years, and what you guys will need to look out for if you are heading into, like I said, any job that requires science communication. So, why it's important. The first and I guess most practical reason is that all the research that scientists do these days, the funding comes from somewhere. And there could be an argument made that we have a moral obligation to communicate our findings and our research to people who fund it. Now, whether that's, like I said, a board of directors that commissions an institute that commissions scientific research, or if it's just the general public, a lot of what universities do is funded by the taxpayer. So that needs to be communicated. We kind of have an obligation to get that out there. a counter argument I often hear to this is, well, the military is taxpayer funded. They don't do any of this sort of stuff. May be true, and there's certain, I guess, valid practical reasons for that, but I don't think we should be comparing ourselves to the military. Scientists are a very different institute, and I think for want of, to use a vulgarization sounding like a wanker, I think we should hold ourselves to a higher standard. And science should be for everyone. It shouldn't just be for that traditionally elite group that has been holding on to it, somewhat gatekeeping it in the past. That's thankfully dying down a bit now, and I'll get into that a bit later on. But the second reason is that we live in a world that is undergoing rapid ecological change. You've heard about this whole scientists say we may be in the sixth mass extinction. I don't think there's any maybe about that. We are in the sixth mass extinction. And it's the others happened at much, much slower rates, despite the fact that some of them were caused by single events. There's species going extinct all the time, whether that's land use, whether it's climate change, whether it's pesticides, fragmentation, lack of connectivity. And we need to be able to show the world how special this sort of stuff is at the moment. We need to be able to communicate that species are important, more importantly, that they are going extinct, and that we do need to be able to do stuff about this. Our ability to communicate science shapes how people perceive species. Somebody who's not directly working on a freshwater project, can you tell me what the top left species is? You are directly working on a freshwater project? Yeah. Anyone? It's a brown trout. There we go. They're native here, but they're sure as hell not native in Australia. Can anybody tell me what the bottom right species is? Yeah, you can do this. Yeah.
Is it a carpfish?
Yeah, it's a carp. Yeah. Also not native to Australia, also invasive. Now, these two species both have almost the exact same effect on our native galaxid species. I know everybody thinks in terms of Australian fauna and koalas, kangaroos, that sort of stuff, but our fish species are incredibly exotic. And these two species have exactly the same negative effects. However, because of how scientists have talked about them in the past and the fact that scientists have often been responsible for stocking one and the other, the public's perception of them is very, very different. Now, some of that also does have to do with the fact that unless you're from Eastern Europe, carp generally has the stigma of tasting like mud, and brown trout is quite a good eating fish. But, having said that, science has had a big role to play in this as well. And we haven't done a good job of telling people that, yeah, brown trout are just as bad for the environment as carp. There's similar stigmas in Norway about certain bird species, whereby two of them have exactly the same negative effects. I've forgotten the species names. But because one looks nice, public don't care about it as much. So we need to be able to communicate ideas like this. And at the same time, we're in a world where this climate and environmental sensibility is rolling through everywhere. It's huge. You can't really ignore it anymore. Trump may be a moron who doesn't believe in science, but he has to acknowledge it. How he acknowledges it is questionable, to say the least. But you also have companies like Stat Oil, who don't really have the environment's best interests at heart, I would argue. But they've had to change their name to Equinor just because public perception has shifted so much. Now, at the same time, as we live in a world where you can't ignore science, climate science, environmental issues, we also live in a world where trust in science is starting to wane a little bit, I would say. Now, a lot of people, when I talk about this, say that's not happening in Norway, that's not happening in Europe, that's an American thing, that's a British thing, that's happening in Australia as well, which it is. But they've done a lot of these same sort of surveys in Norway, and it is happening here. Public trust in science is starting to wane at a time where it should be just getting bigger and bigger. So, this is one of the key messages I want you to take home today. Saying "we told you so," standing on the sidelines shouting "industry is bad, banking is bad, private property owners are awful, the rich are terrible," doesn't really help in ecological science. We have to be able to influence and work with these people to change their minds. If you have a better informed public, and if the public has a deeper understanding of scientific concepts, if we communicate it better to them, that shifts the way that larger companies and governments act. I don't think that's too naive to say. So, why has it been a bit crap traditionally? Why do we why have we gotten to the point where people don't believe certain things in science or see scientists as too elite? And that has a lot to do with the fact that scientists themselves have seen themselves as elite in the past. Does anybody know who the four guys on the right are? So that macroecology, I'm going to close this now by the way. That macroecology lecture I gave, where I told you didn't have to bother learning the names of old white guys. This is them. Obviously not the Far Side cartoonist. That's Gary Larson's representation of the scientist, which is, again, a little bit of a problem. But scientists had traditionally been gate-kept by old white men. It's been a real problem in the past. It's starting to change now, not as fast as it should have. And when I say now, I mean in the last 50 years. Again, not as fast as it should have. That's been one problem, science being in the grasp of a few. It hasn't helped that's kind of a positive, or I guess I should say negative feedback loop in this case, whereby scientists have traditionally been portrayed as white men in lab coats. If anybody knows of a bearded, kind of dowdy man who's got the glasses on his face all the time that's not Bob O'Hara, then congratulations. There are people who conform to that role. Having said that, Bob is a fantastic man and not at all what you'd call a typical scientist when you do get to know him. But this perception of a scientist has led to it being seen as for old white men, which it's not, and it should never be. Within science itself, everybody knows what these are? It's just, I don't know, what do you call these in Norwegian? Silo? Okay, silo, yeah, exactly the same thing. Silo is, I presume it's used the same way in Norwegian, it's just a term for things that have been shut off from each other. And that's how science has been, with other disciplines as well, like social sciences and that sort of thing, but even within itself. 40 years ago, you could be in your office by yourself studying a worm in and echidna's butt, and that's fine, and that would make some good research papers. But you wouldn't be talking to statisticians, you wouldn't be talking to social sciences, population ecologists wouldn't be talking to genetic ecologists, that sort of thing. All these disciplines were very much shut off from themselves, and it made them really develop their own language that made it inaccessible to people outside. And that was kind of confirmed that it's still an attitude today. When I met this guy in Melbourne last year, and I asked him, how he described his science to the public, and he said he didn't because nobody would understand him. Now that is not the public's problem, that is his problem. If you can't explain what you research to the public, you don't understand it well enough, or you're not good enough at communicating. And some people don't need to explain their science to the general public. There's theoretical statisticians who understandably would have a bit of trouble explaining exactly what they do to a general audience, but in case their general audience is the people who use that theory. And I would argue that most theoretical statisticians could potentially frame their work for the wider audience as well. Does everybody familiar with the concept of the ivory tower? It's kind of, being in an ivory tower is this perception of oneself as separated from the rest of society. So it's what we're talking about, but in this sense it's more kind of elitism. And that has dog science as well, this perception that other people can't do science, non-scientific people can't be involved in it. And with the rise of participatory or community or citizen science, whatever you want to call it, that's shown to be quite false. We can get the public out there helping out with different aspects of science. Some of it's quite easy. Obviously, putting it all together, you need to have a good fundamental knowledge of the scientific process and what you're doing. But anybody can do science with a push in the right direction. But it doesn't help that this is the kind of language we use. And I'm not talking about German. I know one of them is in German. Although traditionally that was the language of science at some points in history. But I'm talking about this kind of, instead of saying something like where fish will be in the future, we talk about the complex interplay of climate and land use changes, species dispersal, movement barriers. It's not impossible to understand, but it's kind of off-putting for a regular person. What else have we got here? This is from a colleague, by the way, who is a fantastic science and a great communicator. It's just that, you don't use that in scientific journals. Environmental filtering governs the spatial distribution of alien fishes. It's not really friendly language. Nobody who doesn't like science or isn't forced to read it for some stupid essay is going to want to read something titled that way. This is the second big problem, the perception of science that's come from, admittedly, within the discipline itself a lot of the time. But that's been picked up and replicated and amplified by the media. And when I say the media, I mean everything. I mean the news, I mean newspapers, I mean movies, TV, that sort of thing. That all gets amplified. This is kind of the pinnacle of it. Because the news and TV and cinema often, and it's not their fault a lot of the time, they portray science as this absolute kind of thing, this thing that has a perfect solution for everything. Given enough time, scientists will find a solution. Everybody still thinks that the cure for cancer is a second away. But science isn't that kind of perfect cure-all solution. It is dirty, it is messy, it takes ages, it takes so many mistakes. Has everybody heard I can't remember which Greek philosopher it is, but the whole the more you know, the less you know kind of thing? That is very much science. The more we find out about one certain thing, the more uncertainty there is about it. And that's just not communicated by the media. That's not how the public sees us a lot of the time. And this was kind of the zenith of it. Science doesn't work all the time. Richard Dawkins, who should have known better, says this all the time. And he should know that science isn't that way, and portraying science that way doesn't help us. This is another, I would say, more famous these days public figure. Now, does anybody watch this guy on a regular basis? John Oliver, I'll say his name. So this was from a piece he did on genetic editing. I want to say middle of last year. And scientists were talking about, in a very not Jurassic Park kind of way, reproducing a woolly mammoth. Now, when scientists talk about reproducing dinosaurs, non-bird dinosaurs these days, or megafauna like this, they talk about kind of editing genes, and with that you just do it step by step. You can't just switch around a bunch of A's, G's, C's and T's, and all of a sudden you've got a woolly mammoth. It happens stepwise, as with anything. I mean, we never jump all the way to a solution. There's little steps along the way. So, I mean, it does look like a wrong elephant or a mossy elephant or something covered in fungus, but it is a much more accurate representation of how the scientific process works. And now for a more practical example, back to the carp. The media labelled the release of the herpes virus, a very specific herpes virus that only is thought to not be transmissible to other fish species, let alone humans. They labelled the release of this as Carpageddon. Now, again, as an Australian, I can tell you that biocontrol is never 100% successful. I don't think there's many cases of just completely wiping out an invasive species overnight, for sure, anyway. And when you do something like release herpes into the water and call it Carpageddon, people expect a slaughter of carp that will leave the rivers red with their blood or whatever, and they'll all be gone within 5 weeks or something. That's never going to happen. Never going to happen. Even if they do release it, which they might not, because, we've learned from our mistakes. You've all studied the cane toad by now, I hope, in any case. And we want to make sure that this isn't going to A, transmit to other fish, B, when all the carp die, that's not going to cause massive toxifying of the waters. So it might not even happen. But if it doesn't happen, now that it's been called Carpageddon by the media, people are going to be pissed off, and they're not going to blame the news media who reported it this way. They're not going to blame Barnaby Joyce, who's a Australian politician of questionable repute. They are going to blame science and say, oh, science promises something and they didn't deliver. Sorry, I'm ranting a bit. I'm obviously quite passionate about this. But it's not the media's fault. I've portrayed this in a couple of ways as the media's fault. It's not. It's a problem that comes often from within science. Now, this is a scientific paper. Again, not friendly, but I'm sure you guys can understand the basic gist of this title. There was a study at a health centre in the UK that basically wanted to ask the exaggerations that we find in the press. Is that coming from the media when they report a study? Or is that a result of the press release by the scientists themselves? And almost 63% of the time it was the scientists themselves. It's people in the scientific community not understanding that the media needs a narrative, thinking the media needs big flashy numbers and kind of exaggerating their own results. Now, this doesn't happen all the time. I think I've already spoken about the report that came out last year. Did people read it? The one that supposedly claimed that 60% of the Earth's biodiversity had been killed in the last 45 years? Do people remember that? Yeah, so it was an exaggeration from within the report. It was two numbers that did actually mean something within that report that were taken well out of context. That was the media's fault, I feel. But there was also a report that came out, and it would have circulated a lot more recently, and I think it's task 7 or task 8 on the assignment, that dealt with the insect apocalypse and bugs dying out everywhere. Now, that was the scientists' fault. I'm not going to be so subjective as to say I believe that. I'll say I have heard myriad of scientists, including one who got up at a recent conference and just said flat out it's their fault, they did a shit job of communicating their science, and they put a lot of bias into their paper. So we really need to be better at understanding how the media works, giving them maybe not the story they want, but a story that they can communicate that is accurate. So, I've ranted a bit about the state of scientific communication in the past. Is it getting better? I think it certainly is. Does everybody know what an elevator pitch is? No? Okay, so it's a term that came from sales originally, whereby if you get into an elevator with somebody, you can tell them what your project is about before you're both out of the elevator. So essentially, it's a concept that they'll teach you in more advanced science communication classes, whereby you should be able to convey your research in 15, 30 seconds or a minute. And that didn't exist maybe 15 years ago. That's a really recent thing that people are taught nowadays to get their research across as quickly as possible. Now, it's not just about the time intervals, it's also depending on who you're talking to. You should have a different elevator pitch for your friend who works in banking, for your friend who has a bachelor's degree in science, for somebody you meet who works in the same specific field as you. So I talk differently about my project to my mum, to my friends who, like I said, have bachelors in sciences, to people I meet at freshwater conferences around the world, to people I meet at specific Salvelinus char-based conferences. You have to be able to adapt that message. And like I said, that's something that didn't exist 15, 20 years ago. There are tons of research grants, a lot in America and Britain now, whereby before you can get the grant, you have to be able to say how you're going to communicate your findings to the public, which is a real step forward. It makes people consider scientific communication before they've even started the project. It encourages people to get the community on board before they've started the research that's potentially going to aid or affect the community. It involves more people in science right from the start. Policy relevant ecology is a huge trend nowadays. I've been to 2 conferences in the last 2 months that have had this as their central theme. And it seems to be more and more ubiquitous in science. Scientific communication classes, I don't mean a silly little lecture like this one, I mean like dedicated courses to this sort of thing are popping up more and more. They've started in Norway as well, not too much, and it's only at the PhD level, but they're getting there. I spoke to a guy called Carsten Rabeck. Does anybody here know Carsten Rabeck? He works at the the National Museum of Denmark in Copenhagen. He has a media team inserted into his department that do yearly coaching with the PhD and postdocs to help them dealing with the media and scientific communication, that sort of thing. So this is starting to crop up. There's more and more support for scientific communication, as well as the words being thrown out there a lot more. Interdisciplinarity has been a huge thing for about, I would say, 30 years now. You rarely, if ever, see a paper these days with just 1 or even 2 people's names on it. Normally you'd have 4 or 5, some of them from different disciplines. The social sciences are starting to creep in as well, which are I'll get into them later, but they're really important for science communication. Although, again, they're not creeping in as quickly as I think they should. So, for those of you who are going to go on, be it in academia, in industry, with some sort of scientific backing or requirement, what do I think, and I emphasize think because there's a lot of different opinions about this, what do I think you guys should look out for? So, there's 5 things I'm going to go over now. The first is the problem of uncertainty. The second is your audience, knowing how to speak to them, how to approach them, what sort of language to use. The third is having a good understanding of the media. The fourth is the concept of telling stories. Does anybody know what anthropomorphism is? Can I get a definition? You're making eye contact with me, you do it.
When you put it on the point of view of humans?
Yes, yeah, you inject some sort of human traits into your animal species. That could be from anything from the talking caterpillar in Alice in Wonderland to referring to killer whales as mean, or even calling them killer whales when you think about it. And listening to the social science as well, and why we should be listening to the social sciences. So, uncertainty is a real problem in science because the public don't want to hear uncertainty. People don't, no, that's too much of a generalization. But people don't like us to come out and say, hey, this is going to happen, probably. They want definite answers. When you're dealing with policymakers, they don't want like a 30% chance either way. They want you to be able to tell them what's going to happen. But conveying uncertainty is important for 2 reasons. One, people need to know that this sort of stuff isn't precise, that there's always the chance, the eventuality that things could be much worse or much better, and you can plan for that. 2, we need to cover our own asses. If we say that something's going to happen and that 5% chance that it doesn't happen eventuates, we need to be able to say, hey, well, this is always a possibility. Where's that there? So, this guy, you guys are Norwegians, do you know who the guy on the left is? Seeing some nods? Rasmus Hansson. Yeah, so he's the former leader of the Greens and the WWF in Norway. He came to give a talk a couple of weeks ago. We did an interview with him, it was fantastic. But he kept talking about what will happen, what is going to happen in the environment and that sort of stuff. And it's kind of grating to hear as a scientist because we shouldn't be talking about certainties. We should be talking about likelihoods with where there is a good amount of consensus, but flat out saying we know something, I don't think is a good way to go about it. But it's important to be able to use that language when you can, because as a scientist, in science, we are constantly going up against conflicting opinions from people who work, say, in economics, in politics. And to make a rude generalization, a lot of them are very comfortable stating what they know and what they think is going to happen. And it can be difficult. If you're going up against somebody with a conflicting view who is conveying absolute surety and certainty about what's going to happen, and you're sitting there saying, well, there's a 50% chance you'll see eutrophication in this lake, but there's a 50% chance it'll be even worse than that, and you'll see complete marine freshwater die-off. It's easy for people to just say, oh, okay, well, one of them actually knows what they're talking about, so we're just going to go with them. And the message is that that person who says they know what they're talking about doesn't. Has anybody ever heard of Philip Tetlock? No, me neither, but I know the book. And he showed that across the UK, and I think America as well, although I might have those the wrong way around, uncertainty, political commentators who were asked for their opinion on a political event were wrong more than 50% of the time. You are better off with a coin flip. He also showed, which was really telling, that those political commentators who were more likely to voice their opinion, who were more likely to give their opinion often without being asked, were more likely to be wrong. So scientists, natural scientists are no more certain of what we're talking about, or no less certain than political scientists and social scientists. It's just that for some reason the language has diverged along the way, and often these outspoken people on the political and social science realm, they are unafraid to talk in certainties. So you're going to have to think about how you want to convey uncertainty. Personally, I believe we should, wherever possible, because we need people to realize that this is something that comes with science. We need to do away with that perception of science that's been given by so many films, so much media, and just, again, that positive feedback loop that the public generates about us. So, knowing your audience is the second big one. Now, like I said at the start, your audience could be anything. It could be 5-year-olds, it could be 85-year-olds, it could be a theoretical physics group, it could be a banking board. And you need to adjust your message based on who you're talking to. If you go too complex, you're not going to reach anybody, you're not going to engage with people. If you go too basic, you're going to patronize people, you're going to make them feel like you don't respect them. And you kind of have to look out for that, because if you don't get the tone right, you're not going to be able to engage people. My general rule is that you should assume that you're talking to an intelligent person, whatever their age range. Obviously, it's going to be more difficult if you don't have too much interaction with a 5-year-old to gauge what a 5-year-old who's intelligent sounds like. But that can be helped with research. Borrow one of your cousin's kids. Or if you're talking to a room of adults who don't have much knowledge about science, assume they're intelligent, but just assume that they don't have much of a scientific background. So don't change the complexity of the concepts, change the complexity of the language. Because most people, if you explain a concept well enough, they can grasp it. But if you use language that's couched in jargon and massive numbers of syllables, it is going to put people off. But again, a lot of this is just research. Read talks, listen to talks, read books that are aimed at different levels. Do a bit of research if you go into a workshop, council meeting, board session, kids' classroom, that sort of thing. Understanding the media is a big one. I was talking earlier about the fact that the media gets us wrong a lot of the time, and a lot of the time that's scientists' fault. And I was also whinging about the way that science is portrayed in movies. But we can't really help how science is portrayed in movies. Movies are different from, movies and TV are very different from real life. They require an antagonist. They require a quick solution. Nobody wants to watch somebody run computer simulations for 2 hours and come up with something with a 40% chance of being right. Understand that the media needs a story, a narrative. Find your message, whether you're talking to somebody from a news outlet, whether you're, I don't know, putting together an article. Find a message, find exactly what you want to say, and stick to it. And that's going to be really important in the essay. Figure out maybe a couple of points to build up to that message as well. Telling stories can really help too. Weaving a narrative is how people have communicated information throughout history. It's worked pretty well. And you've got to be able to latch onto that. Like I said, this is Anne Sverdrup Tryggvason. I hope I haven't butchered her name too badly. Has anybody heard of her before? Yeah, so she works with insects, mainly. She's got a great book out called Terra Insecta. Terra Insecta, yeah. I think in Norwegian it's Insectenes Planet, which I'm trying to read at the moment in Norwegian and not having much luck with. And she does a fantastic job putting human values onto insects, uncharismatic species. Uncharismatic species are a real headache for scientists because as much as we care about them, as we should care about them, and as much as the rest of the world should care about them, if something's ugly, often it's going to go under the radar. There was a fantastic talk down at Kalvsnet earlier today by a woman called Erica McAllister, who works with flies and mosquitoes. They are some of the most important species in the world, but they carry diseases, and they're annoying, and they bite you, and people don't care about them, despite the fact that they are going extinct at dying out at alarming rates, and are really important to a lot of ecosystems on the planet. So weaving stories around these sort of things has been a huge boost for people like Erica, for people like Anne Sverdrup Tryggvason. Making people care about them by transferring human values can be dangerous at sometimes because they can often rebound and go in the opposite direction. Has anybody heard of what mallard ducks do to each other? Look, I won't go into it here, but ducks are horrible things. And we should not murder them all, but keep them somewhere else. Right, these are two books by Dag Hessen. He does a very similar thing. For Kommer Fra is for, I don't know, 7 to 8 year olds. It's about explaining evolution to a child through telling a story of where she comes from. The girl asks the father, "Where do I come from?" He says, awkward conversation about sex, whatever. But no, the girl's saying, where do we come from? And this is, where do we as a species come from? And this is a really complex concept to explain to a 6-year-old. I know how evolution works. I can't explain that to my kid. I don't know how to. But the story that he tells is a really effective way of getting that across. And it's the same with Livet fra A til Å. It's a book about somebody who gets on a train to his exam and has no idea what he's doing going into his exam. The train trip to the exam takes about 8 hours, which I think Dag Hessen may have underestimated people's commitment to a good university, but it's a really cool story whereby the train is essentially a time machine and takes him across, human evolution, the planet from A to Å, essentially. And they're really, really well-woven stories that have great scientific messages along the way. Again, most of these two are for kids, but hers aren't, and they work really well. So, this is the last point I've got before we'll take that quick 15-minute break. If you currently study literature or history or sociology or another language alongside ecology or science or environmental science, nature management, whatever you're doing, keep studying it. Whether you go off and study that in more detail and leave science alone, that's fine. But we need more diverse perspectives in science. The social sciences essentially talk about how people, how cultures, how societies work. And that is a huge boost for scientific communication. Whether you're going into try to influence policy, try to influence people's perception of science, if you know something about literature, if you know something about cultural anthropology, that is going to help enormously. The more perspectives we have in science, the better science works. But at the end of the day, if you don't like scientific communication, you don't have to do it. There are tons of people out there who are doing fantastic science that are uncomfortable talking to the public, that don't like doing it, and that is absolutely fine, because if you don't like something, at the end of the day, you're not going to be very good at it. If you really don't enjoy what you're doing, then yeah, you shouldn't be doing it. This essay is an attempt to introduce people to it, kind of force people to at least give it a go. But if you hate this essay, you're still going to hand it in, but maybe that's something that you've got to consider going into science communication. The fact that you don't really want to be able to communicate science. Like I said, that's fine. You don't have to. But we want to give you the opportunity to see whether or not you like it. So, I'm going to finish there. We'll have the 15-minute break, unless people have questions at this point. Yep.
Why do we do a scientific communication in this specific course and not other courses?
Because they haven't let me freely choose what I want to do for one lecture in other courses. They have in this course, so yeah. There should be, I think, like a 1-week course or something dedicated to it at the start of most science bachelors, if not probably masters. But I think bachelors would be better, but it's less likely to happen. Okay, all right. Well, like I said, I'll see you guys in 15 minutes, and we'll start talking about the essay in more detail. Yeah, of course, yeah.